Hi, I'm Jeffrey Learn, and my project was NASA for Dinner. The purpose of NASA for Dinner was to work on COVID bot, have a robot that cleans up after you and also keeps the staff in the restaurant safe. So then that's how COVID bot was thought about.
Hi, my name is Melissa Garcia. I'm the aesthetic designer of NASA for Dinner. So I'm going to be explaining a little bit more about what my job was about. In our team, we wanted to make a robot that was mechanical excellent and also very pleasing for the people. With this said, we decided to make a robot that wasn't too much to the point where people would be messing with it, grabbing it because it was getting their attention. We try to make it blend in restaurants. So to the point that we decided to make it a shell, meaning that it's really easy to take on and off, and the customer can choose any color they want. So for example, our shell covers from top to bottom of the robot, meaning there's still a layer inside, which is a box that has all the mechanical things like the motors and sensors. The shell covers this with a very minimal design, but also not boring. So we decided to find the perfect match that wasn't too much and it wasn't, too less. So this was very easy for the customers to put it on and just hide all the cables inside. But also this part, since it covers from top to bottom, it can be chosen any color they want. So for this project, I wasn't really too, I would say, techno. My field is more in design, which is civil engineering. In design, so I decided I wanted to take over the aesthetics. I've seen my team work on the mechanical side, and I've seen them grow and learn a lot of things, and honestly, there's a lot of things I learned from them, and I am grateful because we all learned together.
Hey, my name is Zan, and I'm in the group NASA for Dinner, and I was in charge of the coding aspect, along with two other students, Byron and Andrew. So before coming into this project, and even now, I still have like a very limited knowledge about coding and stuff. So this whole experience has been very thought-provoking, and I learned a lot. So in the project, one thing that we dealt with were NRF receivers and transceivers. In essence, what we're trying to do is have two robots communicate commands with each other. And as you can imagine, that leads to a whole host of problems. But due to the sake of time, I'll only talk about one, which was timing. And the timing was very difficult to nail. Sometimes robot A will move and robot B will move. Sometimes robot A and robot B will move at the same time. Sometimes robot A won't move and robot B moves 30 seconds later, right? That was a really frustrating ordeal to overcome. And we fixed that though. We fixed that by using a timeout function. So this project has been a very thought-provoking assignment. We banged our heads on the table multiple times, but no pain, no gain. But I just want to give thanks to Brian and Andrew. Those two were amazing and they were super helpful with this getting the coding done. Same with Melissa and Jeff. Those two did a perfect job with the design aspect of the project. And at the end of the project, I can't be more content than I am right now. Everyone did an amazing job, and I'm very happy about our progress today.
Hi, my name is Byron, and I'm with the NASA for Dinner team on this NASA internship thing we're going through. My position within it is the software side of things. My job there was really just to learn and try and implement most of the code within the software side of things. So we would implement motor code, we would implement sensor codes like the IR sensors on the bot itself. Those were my main jobs. But with coding, with the software kind of things, there was definitely trials and tribulations with this whole thing. So one of the major problems we did have to confront was the Mega, which we were using Arduino Mega at the time. It wouldn't transmit data to the Uno appropriately. So the Uno would send a code, would send a message to the Mega, and the Mega wouldn't pick it up at all due to some sort of interference or something like that, which we were doing so much research during the weekend but just couldn't find a solution to it. So eventually one Friday, me and Zan went to Starbucks. We got together just to kind of solve it on our own because the rest of the teamers were out. They were busy that day. We tried for 2 hours. It just didn't end up working out. So eventually I came with the solution or the idea, maybe the Uno, we could replace the Mega with an Uno and extend our digital pins because that's what we needed out of the Uno. We needed more pins. So I searched online and I eventually came up with a solution that had popped up. And it was using the analog pins as digital pins, which was honestly such a godsend to have. Because that would save us the trouble from trying to work with the Mega, which would continuously give us problems and wasn't getting anywhere. So eventually we tried it out using the analog pins as digital pins, and it worked out perfectly. So that was a big crisis averted. That was one of the bigger issues I did solve within the software side of things, and it's just been a great thing to go over those little problems, just fall, get back up, and just do all the things. It was really fun to do all that, and yeah.
Hi, my name is Andrew Rivero. I was a software developer on the NASA for Dinner team at Norfolk College. My main role, I guess, aside from just being a software developer, was also acting as a mentor for my colleagues. During our process of development, we ran into some issues, some major, some minor, but we had a lot of fun as well. One of which being when we first started getting the robots to communicate, we used NRF modules, and we had quite a bit of an issue getting them to communicate back and forth. One issue was one would receive signal and the other one wouldn't pick it up. And we quickly found out that it was because we weren't getting anything back because we weren't printing. We forgot one line of code and it ruined the whole thing, which was pretty funny at first. Then we were just pretty annoyed at ourselves. And another time where we were doing more debugging was when we were working right next to another team. NASA 2.0. They also had the same modules as us, and we didn't realize it. So when we turned our robots on to get signal from them, from each other, our NRF module actually picked up information from the other team's robots, so we kept getting the wrong information. And it took us 30 minutes to figure out why we kept getting that problem. So now, instead of getting the data we wanted, we were getting their data. So we spent another hour trying to work around that, which was way above our heads in terms of the work we had to do. We were very unfamiliar with the task, but we had to figure it out. And so we did. We spent a little bit extra time, spent an hour 30 minutes just to get it working. And overall, it's fun. It was fun for me to work with that, work through that, work with other teams, other team members, and just kind of learn and evolve the process. Getting Robot A to work with Robot B was a challenge, but it was a very fun and very exciting challenge. And I really loved working with my colleagues. So if there's anything I could say about them is that they're all wonderful people, and I hope they go really far in life and they achieve everything they want.